Hey guys, it's Friday and our last science lesson for the week. Still in our electricity unit, we're now investigating renewable energy sources. So we had an introduction to that yesterday, that idea of renewable energy sources or sustainable sources, green energy, all those sorts of terms are ones that we are investigating and looking at those as alternatives to unsustainable practices, the practices that involve using fossil fuels. They will run out one day. They also have a lot of pollution associated with their production. And so, for all of us, our future very much depends on our ability to come up with and create affordable and renewable energy sources. So, we're going to investigate just what is being done in those areas. And this lesson will have us start off doing some research, and that research is going to continue into next week as well. All right, so we're going to very much learn about the production of electricity from renewable energy sources. So we're going to use some resources here that I'll show you in the video, but there's also the opportunity to go onto the internet to do further research. Now it does say at the top here that we're researching solar and wind energy. Solar today, and wind energy is the very next one that we go on to next week. So in your worksheets there are tables to complete, and the table has 4 different questions or 4 different sections. And in your research you'll need to do these 3 things. Firstly, describe how the energy source is used to produce electricity. Identify the energy transformations that occur to produce electricity, and describe advantages and disadvantages for each type or each source for various communities. There are going to be different energy sources that actually don't suit certain communities. If you lived in Antarctica, for example, you wouldn't want to have solar power as your source of energy to rely on. I don't think it'd be very successful. Now that all very much comes into our assessment that's coming up for science. So make sure you're learning these things, because each of those 3 different parts there that we're researching do come into our assessment. All right, so in a moment we're going to have a look at the energy chains. We've looked at a few energy chains. We'll see what the one for sunlight looks like, and then we'll go on to these parts here. But again, keep in mind as we're talking about this, how it's produced, the advantages, the disadvantages, whether it's renewable, sustainable, all these sorts of things to do with the production of electricity. All right, so here's the energy chain, which shows sunlight as our source of energy. And then let's see what we need. We know that sunlight falls onto solar panels. Now within those solar panels, they're developed in a special way with different chemicals that allow an electric current to convert. The next step is the inverter, and in fact it's the last step in the energy chain, and the inverter is what actually turns it from a low voltage into a higher voltage of electricity suitable for use in houses. So here now we've got the statements which review our learning. And again, it's a shorter energy chain. Starts with sunlight and goes through to finish with electricity being produced in a usable form for homes. All right, so the worksheet you're working from or needing to complete looks like this, and it's the second sheet that you received in today's worksheets. So it has 4 tables or 4 sections to finish, so make sure you answer each of those. You might even like to be filling them in as we go through these parts now, because you're going to be able to dot point in definite information that you need to keep a hold of, put into your science book and bring it back to school when school resumes. So let's have a look at this one first of all, renewable source of energy, sunlight. So I just have to get out of it for a moment and open it up separately. Here it comes. All right. Renewable source of energy, sunlight. What is solar power? Well, it's sunlight and heat from the sun, and it's a major energy source for Earth. It is renewable and sustainable, and as scientists predict, it will exist for at least 5 billion more years. That's pretty reliable. So, how does it work? Well, currently there are two different systems that use sunlight as an energy source for electricity generation: photovoltaic or PV panels, and then also concentrated solar power. Those terms may not be familiar yet, but we'll find out a bit more about them as we go. So, the first one, concentrated solar power, shortened to CSP. It consists of a large number of mirrors or lenses and tracking systems. The mirrors and lenses track the sun and focus the sunlight. So you know the idea of a magnifying glass is able to focus the light into a beam? Well, these mirrors do that. And so you can imagine if there's a whole lot of mirrors, it can really get a very powerful concentrated beam. And that's used to heat fluids, and it can heat it well enough to produce steam, so it can actually make it boil, which in turn spins a turbine and produces electricity in a generator. So that is known as concentrated solar thermal. And there's an example. You might be able to just see these reflected lights. So here it's all being reflected to a concentrated point, and that's in Spain. Don't think we've got any of those in Australia, none that I'm aware of anyway. All right, and the other one is the one that we're used to seeing, the photovoltaic solar panels, and we have them on our roofs. So these solar panels are made up of solar cells, and these convert sunlight into a low voltage electricity. An inverter has to be attached to that. That changes the low voltage electricity into a high voltage electricity ready for us to use. So they're placed on homes and business rooftops, and they supply electricity on a fairly small scale, usually enough for that house or business. But they are also being used in large scale power stations. Now there is a field, a whole range of those photovoltaic solar panels, and that particular picture comes from Portugal. And obviously it's placed in an area which gets a lot of sunlight, regular sunlight, so it's a reliable source of energy. All right, there are advantages in solar energy, and so these are some of the things that you might jot down on your worksheet. You might want to have 3 or 4 of these down. It's renewable and sustainable as an energy source. Renewable as in the sun will keep shining. Might go away at night time with the rotation of the earth, but it's going to be there the next day. Sustainable means it's not going to run out, it's going to keep on going. Once solar panels are installed, there's very little maintenance needed. So after the initial cost, it doesn't cost very much to continue it as a source. Some forms of solar panel get quite noisy. Sorry, not solar, but of electricity production. But solar power, it's silent, no noise created here at all. There's no pollution, sunlight's free, and solar panels can be set up on homes and business rooftops to supply electricity as required during the day. A lot of advantages there. But there are some disadvantages. Currently, electricity generated from solar power can only occur during the day when the sun is shining. Kind of an obvious one. And therefore, because it is reliant on the sun, when it's cloudy, that reduces its efficiency. But there's also a relative expense to install these initially. So I know that if you're looking at installing them on your home, it's at least $3,000 and then more depending on how much you want to put on your home. Okay, so that's it for that particular slide. Let's go on. All right, so, oh, silly me, I went to the wrong spot. That's where we're up to again. We're going to have a look at another one in a moment. We're going to look at this video called Solar Power. And again, you might like to fill things in as you go.
While it may not be the answer to all of our energy problems yet, There's one energy source we have plenty of: sunlight. In fact, the amount of solar energy that strikes the surface of the Earth in 1 hour is more than enough to supply every person on the planet with electricity for an entire year. We currently have a number of methods to harness the extraordinary power of the sun. Most involve converting sunlight into electrical energy. So, how's it done? The most common way to perform this energy swap is by using a photovoltaic cell. These make up the blue solar panels you typically see on people's rooftops. Most photovoltaic or PV cells are made of the element silicon. When a photon or packet of energy from sunlight hits one of the silicon atoms in the cell, it knocks off one of the atom's outer electrons. These free electrons then make their way toward a metal conducting strip on the solar cell's surface. The strip transports this steady stream of electrons, the electrical current, out of the cell so that it can flow into the power grid for people to use. There are other types of solar power as well. Concentrated solar power, or CSP systems, use giant mirrors to direct sunlight onto a small target. The concentrated light is used to heat a fluid, which in turn is used to boil water and create steam that turns an electrical generator. The great thing about both of these solar energy systems is that they are totally renewable and don't emit any greenhouse gases. So why don't we produce all of our electricity this way? To begin with, solar technologies aren't particularly efficient. Most convert less than 25% of the sunlight that strikes them into usable electrical energy. To top it off, we don't have good ways of storing solar energy. So, for the most part, we still can't use it at night or on cloudy days. In other words, even if we plastered every rooftop in America with solar panels, they still wouldn't completely replace fossil fuels. Finally, solar power costs more. PV cells have become cheaper to produce in recent years, but solar technologies are still relatively costly compared to coal, oil, and even some other renewables. If we can work out these issues, efficiency, storage, and cost, solar energy really could begin to replace a significant portion of the fossil fuels we consume. We're not there yet, but the technology is getting better and cheaper all the time.
Very good. All right. So that gave you some information. If you still need to jot down some more things, there's 2 more sites that I've included here that you can research from. So just type in those into your search for Google, and that will take you to very much suitable places that will allow you to do more research. So the worksheets look like this. You've no doubt filled some things in. Ideas like, if you're talking about how it's produced, one of the things that you should have is the sun's rays strike solar panels, something like that, plus a few more dot points. So if you have 4, 5, 6 dot points for each, we're going pretty well. Your energy chain will look like that flow diagram, and it can have pictures or it can have words, so something along those lines. Then for the other 2 questions, talking about advantages and then disadvantages. One advantage that you might have had in already is that it does not create pollution. And a disadvantage could be it's less effective in cloudy weather. So there's a lot of things there. On this page, if you've got 3 things down for each of those sections, I think you're doing pretty well. All right, done and dusted. Good luck researching if you need to do some more research. Fill in this, keep a hold of these sheets, glue them into your science book because they're very much going to be useful when you come back. If you don't have your science book, keep it all together in your bundle so that when you come back to school, it's there ready to put together so that we can work towards our assessments. All right, done, dusted. Catch you next week for science on Wednesday. Have a great weekend. See you now.